In this example, we want to determine if either triangles 2 or 3 is similar to triangle 1. I've just numbered them for ease of conversation. To do this, what I'm going to check for is I'm going to check to see if the sides are all in the same ratio. In other words, I'm going to check for side, side, side similarity, which is a shortcut we can use to prove two triangles are similar to each other. If all three sets of sides have the same ratio or the same scale factor, we know that the triangles are similar. And then if they are similar, we want to write a similarity statement. So in this case, what I've done, because sometimes it's hard to see what matches up, the way that I think of this is I think of matching up the shortest sides, the middle length sides, and then the longest sides. And so let's start with the question, is triangle 1 similar to triangle 2? And so the shortest side of triangle 1 is 8. The shortest side of triangle 2 is 6. So simplifying that fraction, I get 4/3, which doesn't tell me anything yet. I need to check the next lengths of sides. That's why it's called side, side, side. I need all three to match up and become 4/3. So now I go to the middle length side. The middle length side of triangle 1 is 12. The middle length side of triangle 2 is a length of 9. Once again, that does simplify to 4/3, so that's a good sign, but I'm not done yet. I need to check all three. The longest side of triangle 1 is 16, and the longest side of triangle 2 is 12. Simplifying that is good news. It's also 4/3. And so what I can do is say that yes, triangle 1 and triangle 2 are similar to each other because of side, side, side similarity. All three sides have the same ratio, the same scale factor, which is 4/3. I can go ahead then and write a similarity statement. I'm going to do the first triangle alphabetically, which is just ABC, is similar to triangle. And now the second triangle may or may not be in alphabetical order. We have to match up sides and match up angles. This time it does happen to be that way. I can imagine reflecting one of the triangles to get those sides to match up. And so that would be similar to triangle DEF. Okay, let's go ahead and check the other one. Let's check triangle 1 and triangle 3 and see if they're similar. Once again, I'm going to start with matching up the shortest side. So the shortest side of the first triangle is still a length of 8. The shortest side of triangle 3 is also 8. And so that ratio simplifies to 1/1. Just based on that, you can probably see there's going to be an issue. The middle length side of triangle 2 is a length of 12. The middle length side of triangle 3 is 10. Well, 12/10 definitely does not simplify to 1/1. It simplifies to 6/5. And so right there I could stop and say that no, the triangles are not going to be similar to each other. They would need to have the same scale factor. If I wanted to finish this one, I can. The longest side of triangle 1 is 16. The longest side of triangle 3 is also 16. And so that does simplify to 1/1. But two of the same ratios isn't enough. I need all three to be the same. And so no, triangle 1 and triangle 3 are not similar to each other.